plus
B times
b times x plus 1.
plus C times X times X minus 1.
Yeah.
Okay, so what values do you actually want to put in? Want to put in 1? Want to put in -1? Want to put in 0? Okay, let's try the X equal to 1. What do we get?
9.
9 plus 2 is 7 minus 2 is 5. It's going to be 0. This is going to be 0. What is this going to be?
Wait, Dr. J, in C, should it be X plus 1?
C times x plus 1.
What?
It doesn't matter.
Oh,
You just did it in a different order.
Oh, okay, I see what you did. You have X minus 1, X plus 1, we flipped it.
Yeah, it doesn't matter.
Oh. Isn't that 9?
What?
Yeah, that should be 9. That should be 9 because the 2x minus 2 cancels.
9 plus 2 is 11. Oh, 9 plus 2 is 11 minus 2 is 7. 7? 0? 0, what do we get here? To be B is 7 halves? Yes.
Should be 9.
Yeah, it should be 9.
Oh, 9 plus 2 is 11 minus 9.
You need to get your elementary friend.
I need to go and talk to my middle school. Yes. Huh? I don't do numbers anymore.
Oh, no, geez.
So B is 9 halves. So this number here should be 9 halves.
0.
That's how you check. This number here is 9 halves. Okay, what's another good number of X to put in?
-1.
Let's put -1. What do we get here?
5.
9 minus 4, 5 is equal to, that's going to be 0, that's going to be 0, this is going to be
C times 2.
2C. So C is 5 halves. So the number should be 5 halves. And lastly, we'll put X equal to 0. What do we get here? -2. And that's going to be 0, that's going to be 0, that's going to be -1, that's going to be 1, -8. So A is 2. So if I want to integrate this, I'll integrate this. Which is 2 ln x plus 9 halves ln x minus 1 plus 5 halves ln x plus 1.
Plus C.
And that is the first case. But the second case is if you have your factors and they are repeated, then you can do this is your partial fractions. Second case is repeated. Linear factors, Mr. Alding. Linear, no quadratics. Repeated linear factors. So say you have something like this. 2x minus 3 over x minus 1 squared, x plus 1 cubed, x minus 4. Now this factor is repeated. So this is not the correct partial fraction expansion. This is not going to work. Because you're going to get a cubic on the bottom. What is the degree of the denominator? 7. This is not going to work. Now, I'm going to give you on this example what you need to do, but then I'm going to write it with letters. I'm going to do a beast. You're going to say a over x minus 1. You just don't know what a is. Plus b over
X minus 1.
squared. Plus c over
X plus 1.
plus d over
X plus 1.
plus e over plus f over. Now you have to figure out these numbers.
Huh?
You have to account for every power. 1, 2. 1, 2, 3. 1. Now I'm going to write that down using letters. And that is going to work. Oh, by the way, you all should be able to integrate every one of these. A ln x minus 1, b x minus 1 to the power negative 1, c ln x plus 1, d x plus 1 to the negative 1, e x plus 1 to the negative 2, some fudge factor there, f ln x minus 4. You can go and ask your calculus 1 friends how to integrate all of those. You will give them the numbers, of course. Now, let us say we have a general situation. So, P over Q, and of course we are going to assume the degree of P is less than the degree of Q. Q has a repeated linear factor of degree K, say x minus r to the power K. Then you will have to try a over x minus r plus b over x minus r squared plus c over x minus r cubed all the way up to k over x minus r k. Just because it is repeated. If you want to know why, I'll say, well, try this. And you will see it doesn't work. Let me do an example. What is the degree of the numerator? What is, huh? What is the degree of the numerator?
Oh, numerator 2.
What is the degree of the denominator?
3.
We are good to go. So we need to factor the denominator. Anybody know how to factor the denominator? Well, there it is, x squared plus 2x plus 1. How do you need to factor this? Huh?
X plus 1. X plus 1.
X plus 1 squared, huh? Okay, who will give me the correct partial fractions form? 5x squared plus 20x plus 6 divided by x times x plus 1 squared. What is the correct partial fractions form? A over x plus
D over X plus 1.
plus b over x plus 1 c over x plus 1 squared. Now I just need to find it. Oh, if I know my a, ln x, b ln x plus 1, c x plus 1 to the negative 1 to the plus or minus. Or else you count this one. Now I need to find the a, the b, and the c. So I'm going to do it. You put some values of x here, you put some values of x there. You put another value of x here, put another value of x there. Put a value of x here, put another value of x here, you get your a, your b, and your c. I would say do it intelligently. But let's clear the fractions. When I clear the fractions, I'm going to multiply both sides like this. What do we get on the left-hand side?
A times x plus 1 times x plus.
What do I get on the right-hand side?
A times x plus 1 times x plus 1.
What's b times?
X plus 1 times x.
And c times?
Same thing.
X. Be careful with your algebra. Now I have to put some values of x in there. What would be a one suitable value? Negative 1. Huh? Negative 1. This is algebra. If you don't understand this, I'm ask your college algebra friends. I'll clear fractions. I put x equal negative 1. I'll put x equal to 0. And I may have to put another one. Okay, let's do x equal to negative 1 first.